How are you, my friends? This is lecture number 12 from the Calculus 1 lectures. Derivatives of exponential and logarithmic functions. Now, if you look at the objectives of this lecture, we will see the derivatives of exponential functions, the derivatives of logarithmic functions, and also there is something called logarithmic differentiation, which is different from number 2 here. I will explain it in a few minutes. This is important method. We call it logarithmic differentiation. Now, this is all what you need for the derivatives of exponential functions. I put here all exponential functions, 1, 2, 3, and 4. If you have a function like this, f of x is equal a to the power x, the derivative will be, this is the base a, it will be ln of a times the same function a to the power x. Whatever a is positive, this is the base. So the proof will be on the next slide only to read, but you can use this formula. If we have e to the power x, so it will be the formula according to number 1, it will be ln of e, which is 1, we know that, times e to the power x. So now you can take number 2 as a rule. If the function is e to the power x, the derivative will be e to the power x. Now, chain rule version of this exponential function, number 3. If we have a to the power u, u is a function of x, remember, like we will see an example like 5 to the power x squared minus 6x. So it will be ln of a, the base, times the function a to the power u times du over dx. So you find the derivative of du with respect to x. Also, number 4, if we have e to the power u, see this is like number 2, but this is a chain rule, e to the power u, not only x. It will be e to the power u times du over dx. Remember here inside, there is ln of e, which is 1. So remember also, u is a function of x in number 3 and number 4. This is the proof. You can read this at your leisure time. If you have a function a to the power x, this is the steps until you reach the derivative will be the same function a to the power x times ln of a, or ln of a times a to the power x. Explanatory examples. So I put here 4 examples. 3 to the power x, if we need the derivative, ln of 3 times 3 to the power x, according to rule number 1. 10 to the power 5x minus 1. So it will be, the base here is 10. So ln of 10 times the function 10 to the power 5x minus 1 times the derivative of this u, which is 5 only. This one, same, 8 to the power x cubed minus 7x. So the derivative will be ln of 8 times the function times the derivative of the u, which is 3x squared minus 7. This one is nice, e to the power x squared plus sine of x. So the derivative will be ln of e. See, this is the base here is e. And we know ln of e is 1. You can use that always. Times the function e to the power x squared plus sine of x times the derivative of the u, which is 2x plus the cosine of x. So you can write the derivative as this in simple form. Let's find the derivative of this function x squared times e to the power x. This is example 1. The moment you look at this question, you have to think of product rule. You know product rule, u times v all prime, u prime v plus v prime u. So the derivative will be the derivative of the first times the second plus the derivative of the second times the first. So easy to do that. And then after you finish, there is e to the power minus x as a common factor. So it will be 2x minus x squared, all in the bracket, times e to the power minus x. This is the derivative of this function. Another example. When you look here, what do you think? E to the power 2x divided by 2x plus 1. That's a quotient rule. The quotient rule will be u over v prime, u prime v minus v prime u divided by v squared. So the derivative of e to the power 2x times this one, u, minus the derivative of the u, 2x plus 1 prime, times the same function in the numerator, divided by all this squared. E to the power 2x, it will be the 2, the derivative of the u here, 2 times e to the power 2x. This is, leave it. The derivative of 2x plus 1 is only 2. So what can we do? Just simplify, multiply here, 4x e to the power 2x, and then plus 2 e to the power 2x, you can cancel, and it will be 4x e to the power 2x divided by all this squared. Now let's look at example number 3. Given the graph of this function f of x equals x squared times e to the power minus x. So this is the graph, which is not easy to graph, but it is given. Find the coordinates of the indicated local maximum point. There is a point here, local maximum, in the first quadrant that lies on the curve here, this point. We need the coordinates. You know the meaning of the coordinates. We need the x and the y of this point. I put here the meanings for that, just to remind you from the algebra course. Coordinates are x and y of the point x, y. Now we find the derivative of this function, x squared e to the power minus x. The derivative we have seen, 2x minus x squared times, in the bracket, times e to the power minus x. So let f prime be 0 to find where is the local max. Now, if this is equal to 0, this is equal to 0, the bracket, or this one is equal to 0, this is rejected because this cannot be 0. It will be 1 over e to the power x. It's always positive. So this one we can factor x out. So x is equal to 0 or x is equal to 2. So here we have min or max at 0. Also, we have min or max at 2. We need the point in the quadrant 2. So this is the point, x equals 2. So the local maximum is at 2. This is the x value. And then y will be f of 2. So I put 2 in the function here, 2 squared e to the power minus 2. So the point will be 2, 4 times e to the power minus 2. These are the coordinates. Now the laws of logarithms, this is a review. A review here, down here, please. You can look. Complete pre-calculus course, lectures number 5 and 6. You can see the playlist there, please. So I put here the rules, the laws, the properties. The first one, when you have log base A of a product, it becomes addition. This is the most important. When you have log base A of the division x over y, quotient, it will be log of the first minus log of the second. And this is the power. This is e to the power ln of x is equal to x. ln of e to the power x is equal to x also. So if you know the rules, it's okay. If you need to review, you can go to lectures 5 and 6 of the pre-calculus course. Now this slide will give you the derivatives, all logarithms, 1, 2, 3, and 4. The first one, log base A of x. So the derivative, this is logarithmic function. It will be 1 over ln of A times 1 over x. The proof will be on the next slide. If the function is ln of x, the derivative will be 1 over x. Easy. Inside here, you have ln of e. So you know ln of e is 1, because it will be 1 over ln of e times 1 over x. So this is the simplest number 2. The chain rule here, little complicated. You have to check the derivative of log base A of u. And remember, u is the function of x. So it will be 1 over ln of A times 1 over u times the derivative of u with respect to x, which is u prime. So you can write directly 1 over ln of a times u prime over u. Now this one is easier. ln of u. So the base here is e. Here the base is a. So it will be 1 over u, you see, because 1 over ln of e is 1 times du over dx. So directly when you have the function ln of u, directly you can go u prime over u. You find the derivative of the u divided by u itself. That's very nice, number 4. Again, the derivative of ln of u will be u prime divided by u. Now this is the proof of why we have log base a of x. This is the proof here, you can read it. It will be f prime 1 over ln of a times 1 over x. That's the conclusion. Now let's look at some logarithmic explanatory examples. 3 examples are here. We have the function log base 6 of x. To find the derivative, it will be 1 over ln of 6 times 1 over x. Now this one, the difference, instead of x, we have u here. U is x squared plus e to the power x, and the base here is 7, similar to number 1. So the derivative will be 1 over ln of 7 times u prime. Remember, this is the formula here. U prime over u. U is the same, x squared plus e to the power x. The derivative here will be 2x plus e to the power x. Now the last one, we have ln of this. The base here is e. So that's why we don't write here 1 over ln of e, because it is 1. So directly we go here in number 3, u prime over u. U, we write it the same, 4x to the power 5 minus cosine of the x. In the numerator, we write the derivative, which will be, bring the 5 down here, 20x to the power 4, and the derivative of the cosine of x will be minus sine x, and there is a minus, it will be plus sine of x. Let's see example number 4. Find the derivative of g of x is x times ln of x. So clear here, this is a product. U prime v plus v prime u. It's so easy. The derivative of the first times the second plus the derivative of the second times the first. When you simplify, you get 1 plus ln of x. Number 5. Find the derivative of this function. We have y equals ln of 1 plus x squared. The base here is e. You see that? ln means log to the base e of this argument here, 1 plus x squared. So we can say let u here is inside 1 plus x squared, and u prime you have to find. The derivative of 1 is 0 plus 2x. So u prime will be 2x. Now y prime, this is what we need. The derivative of all this, it will be the derivative of u. This is ln of u, which is u prime over u. This is 2x is u prime, and the u is 1 plus x squared. So the whole derivative y prime will be 2x divided by 1 plus x squared. Find the derivative of dy over dx. This is very important question, not easy. You will see now the method. We have y equals the square root of this divided by cube root of this. And we need y prime or dy over dx. Now look at the method. This method, the important method, we call it logarithmic differentiation. Given a function y equals f of x, you can take ln of both sides. ln of y is equal ln of the function. Using the laws of logarithms, you can simplify this. Then we differentiate with respect to x. So remember, this is example 6 here. Then I put the method. Example 6 solution will be the next 2 slides here. You can see that. So this is logarithmic differentiation. It's a method, important method, will make the question easier to find the derivative. And then at the end here, you have to multiply both sides by y equals f of x. So I put this method here between the question, example number 6, and the answer and the complete solution. Now you can use here, if you like, you can use the quotient, but it will be complicated. So look at the nice method. This is the given here. This is the solution of example 6. That's the given here. So I can write it as rational exponent, x squared plus 1 to the power 3 over 2 divided by x cubed plus 1 to the power 4 over 3. Now take ln of both sides, ln of the y, ln of this division here. Then you can use the properties. Ln of u over v will be ln of the u minus ln of the v. See, there's a minus because we have division in the properties or laws of logarithms. So the derivative now, we take the derivative of ln of y, it will be y prime over y. Okay, because ln of y from the rule. So 1 over y, see this is y prime over y, so it will be 1 over y, and y prime will be dy over dx. Remember that, look here. Ln of y, the derivative will be y prime over y. 1 over y, I leave it. Y prime by itself here, I write dy over dx. Okay. On this side now, 3 over 2, find the derivative ln of this u. So it will be u prime over u minus 4 over 3, that's constant. The derivative of ln another u here, x cubed plus 1. So it will be the derivative x cubed plus 1, the derivative over x cubed plus 1. Simplify all that. You will get 1 over y dy over dx equals, cancel here the 2, 3x over x squared plus 1. Cancel the 3 minus 4x squared over x cubed plus 1. We have to simplify this on the next slide. Okay. So this is what we have seen. We combine the fractions here. Okay. And then we have to multiply step 4 here. This is step 4. Multiply both sides by y. Because I need dy over dx. So I multiply here by y. It will be cancelled. So that's dy over dx. Now y, this is what I know here, given. So I put big bracket here on this, and then I multiply by the y. I just simplify inside here, the LCD here, x squared plus 1 times x cubed plus 1. You will get this one, and then leave all this, take minus x as a common factor, leave in the bracket x cubed plus 4x minus 3. And this one you can use, let's look here, x cubed plus 1, see, to the power 1, x cubed plus 1. So you can add the powers here. I put the rule here from the algebra. A to the power m times a to the power n, you add the powers here. So this is x cubed plus 1, that's a. And that's also a, x cubed plus 1. Add the power here, 1 and 4 over 3. Becomes here 7 over 3. Now, x squared plus 1, this is in the numerator, a to the power m, divided here by x squared plus 1 power 1. You subtract m minus n. So 3 over 2 minus the 1. So it becomes half here. That's why it becomes half. So all this brown is the y prime. You can do it yourself and check, please, the answer. Always, please go to the playlist Calculus 1 Solved Questions. Especially this is number 6. You will find more than one question to practice there. This is the end of lecture 12. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.